Okay, so we created arrays at this point, and we just created them by saying this. And of course, like I said before, arrays can hold a multitude of values, like, it can hold number values, or another thing it can hold, of course, are string values. And we can't forget about the Boolean values, which also our arrays can hold, so true or false. But you might be wondering, because, I said at the start that this is actually a type. An array is a type, like a number value is a type, or maybe a string value is a type. So what would happen if we wrote something like this? Well, like I said before, just imagine that this is an actual variable that we created, just like this one. And we created a new array. And you might be saying, is that even legal? Can you do this? And the answer is, of course, like I said, this is just a regular variable that is somewhere on our memory. And we can start using it like a regular array. So this is the name of our variable in this case. And if you wanted to access its first cell, what we would say, of course, is give it square brackets and say 1. And then we would, put any value inside, like 6. And then, of course, we could start filling this array even further. Just go by it. So the next value, of course, is the next index is 2, and just put mango in there because I like mangoes. And maybe you want to get frisky again, and you want to put another array there. And of course, like before, just imagine that this is a new variable that we created, and we can access the first cell of our new array like this, and then we put value 7 in there. And of course, if we print this out, just say print of array of 1, we would get the value of 5, which is exactly what's stored inside. And if we just printed out maybe array of 3, we will get true. And what would happen if we just printed out the array of 4? Well, in this case, if you want to print out an array of 4, which is an array, or just an array, which is our variable, what ends up happening, you get the information that this is a table. A table is an array, just another word for it. And some random numbers which indicate where on the memory it's located, so you don't have to worry about that. But the important part is that this is just like a regular variable, and if you wanted to access the first index of this variable, we would do something like this. And of course, this holds the value of 6, and of course, the same thing holds true for our array 4-3, or 4 of 3, or however you want to call it. And this is another table, and we can access the first value of our new table by just putting an index 1 next to it. And we get a value of 7, which is exactly right. And you might be wondering, okay, so this is nifty that Lua allows us to do this. It's very cool in the sense that, it's very dynamic. And you're exactly right. And you might be wondering, well, how can we use this in an actual game, or maybe anything like that? Well, you can imagine Isaac or any 2D game just as a representation of grids in 2 dimensions. So, for example, if Isaac has a lot of grids that are like maybe 20 by 20 or something like that, and that can be presented very well in a 2D array. So we can say that array of 1 of 1, in this spot where Isaac is currently located, and the array of 1 of 2 is a rock, and maybe array of 5 of 7 is an enemy or whatever, or a boss or anything like that. So this is something that we'll probably work with when we actually reach modding, in that sense, that we'll have some form of arrays that we will access, which will tell us where certain enemies or positions of enemies or are bombs or rocks or whatever are. And you can explain this as first row, first column, first row, second column, and maybe fifth row, seventh column. And we can create 2D arrays, a complete 2D array like this. And this might sound a bit more abstract just because we are using variables and numbers, but let's just create a new grid that's 5 by 5 long. And so first of all, if we wanted to create just a regular array, what we would do, of course, we would maybe do something like this. But we wanted to create a 2D array, which means it's an array which has 5 values, and all of those values are another array. So we can just do it like this. And then we can have to go through our new array. So we create, if you imagine how this for loop works, at first it's value of 1. So our array of 1 is actually a new array which has 5 cells. And what we'll do is, in our first array, which has 5 cells, we'll just put something in. So of course, let's just put I times j for no particular reason. So what ends up happening, we create our first array, which is array of 1, and we go through it and assign every cell in it its value. So array of 1 is 1 by 1, array of 1, 2 is 1 by 2, 1 times 2, and array of 1, 5 is 1 times 5. And then we go to our next loop outside, which is I is 2, and on array of 2 we create a new array, and then we go through that array and fill it with random numbers. And if you want to output this just in a logical sense, we would do the same thing. So we would go from 1 to 5 with I, 1 to 5 with j, and we would print it out, and we would see what ends up happening. So our 1, 4 index contains the value of 4, which is okay because 1 times 4 is 4. And our value, for example, 2, 5 contains a 10. And if you want to imagine a 2D array, you can imagine it like a table, like I mentioned before. And the first one is in which row it's located, and the second one is in which column it's located. But I don't like abstracting things, just because I feel whenever you abstract things like 2D arrays to tables, or that we're used to in our regular life, things get a bit confusing, just because then you can't imagine 3D arrays or 4D arrays or 5D arrays. So how I like to kind of present them that I think make more sense is like this. So let's imagine that we have a 1D array, and that is simply a symbol for an array. So this means that this is an array, and each of this array in particular has 3 values inside, and its first cell, so its first kind of container for a value, just contains a number 1. And the second cell contains a number 2, and the third cell contains the number 3. And that's legit. That's something that's very straightforward, I feel, and I don't have to explain it too much. But what happens with a 2D array? Well, a 2D array has, again, a regular array, like outside, like this one, and its first cell, so to say, so this is its first cell, if you kind of see the brackets, doesn't contain just one value, but what it contains is yet another array. And of course we can access that particular array by going into our first cell and then accessing the first value of our first cell, because that's also an array. And of course, if I want to imagine a 3-dimensional array, this particular cell wouldn't contain an actual number, but it would contain yet another array. So in this case, this would be maybe a 3-dimensional array. So you can kind of simplify all of this to just imagining that 2D or 3D or 4D arrays are simply nothing more than our cells, instead of holding values, are holding yet another arrays. And if you just gonna imagine what exactly is going on there, if you just wrote something like this, our array of 1 contains the value 1, that's exactly what it contains, and our second array of 1, if you just said it, it contains an actual array. And of course, if you wanted to access this array, what we would do is write something like array of 1 and 2, and that would access our second cell in this particular array. So I feel that is the best way to kind of understand it. And once we go through a few examples, I hope that these arrays will kind of start making sense. But the thing I feel that is most important is that you don't abstract it too much, and that just remember that arrays are just like any other type in Lua, and they can hold values in cells. And it's actually true for other types in Lua as well. So this is maybe just a stepping stone to really understanding what's going on. But for the time being, because I know this is very confusing, and at this point it's usually when a lot of people just start, kind of not getting it, please, I urge you to ask questions. I'll have a lot more examples in the next few episodes. Today we're just gonna look at some basic arrays, some basic examples, how we can do certain things, and then in the next episode I'll actually start providing a bit more complicated examples to see how we can start doing certain things with 2D arrays. But for the time being, know that they exist and know that they are very useful, and I urge you to kind of play with them, to kind of create a few and try to understand the code I've written maybe, and of course ask questions. I'll be more than glad to answer you if you have any particular questions. And yeah, with that said, let's just go straight to the examples, because I think they hold a few interesting things that I can also explain about Lua. Our first example wants us to create a program, and we are given an array of numbers, and what it wants us to do is go through this array and find the index of the biggest number and also the value of the biggest number, and then print it out at the end. And we can do that in a few ways, but when we'll get to the actual example, I'll show you maybe an elegant way that is usually done when we're dealing with such problems. Okay, so our first example is a very simple. We have an array that has given numbers inside, and we have to develop an algorithm, I guess, that finds the biggest number and its index in this particular array. And how can we do that? Well, a very common way of doing this, and it's something that's very useful in general. I feel this is one of the basic things that you'll learn, and it's something that also comes in very handy whenever you're doing anything. So for example, let's imagine you're looking for an enemy that has the most HP, or maybe you're looking for an enemy that's closest to you or anything like that. What you end up doing is, first of all, we remember the first index, and we remember the value of the first number. So in this case, we just remember the index 1 and the number 1. So up until this point, we only check the array up until to the second index. So if you just look at the first number, of course the first number is always the biggest. And then we go into this our loop, and we start with the second index, because remember, at this point we are assuming that the first number is the biggest. So we have to start with the second one to start comparing it to the previous one. And then what ends up happening, of course, we go from 2 to our length of an array. In this case it's 6, but of course this function kind of knows this for itself. And what we do is compare the current value, so the current value in our array, so the second one at the start, to the biggest number that we found so far. So the biggest number that we found so far is of course just the first number, and in this case our second number is actually bigger than our first number. So what we do is remember our new value as the biggest number, so 10, and we remember its index as 2. So at this point, what ends up happening, of course, is because we checked up until this point, we know that the second number is bigger than the first one, and at this point we are assuming that the second number is the biggest one in the table or in the array. So we go to the next iteration of the loop, and this I increases to 3. And now we are looking at 12. So is 12 bigger than our biggest number that we found so far, which is 10? And of course it is. And then we do the same thing again. We remember 12 and we remember its index, which is 3. So now we go to the next iteration of the for loop, and we are now looking at the number 5. Is 5 bigger than our current biggest number? And of course it's not, so we don't do anything. Then we go to 7. Of course, is 7 bigger than our current biggest number, which is still 12? Of course it's not, so we just don't do anything. Is 8 bigger than our current biggest number? And of course it's still not, because 12 is still biggest. And what ends up happening is this is actually the end, because we got to the end of the array, and we just print out the biggest index that we found and the biggest number that we found. If you just run this, you can see that the biggest number is located on index 3, and it has a value of 12. So this is something that is very useful in many situations, especially when you're kind of dealing with finding the biggest number or the smallest number. It's a very common problem, and something that is probably going to come in a lot of situations, especially when you're developing mods. Okay, so for our second example, what is given to us are some enemies' X and Y positions, which of course, if you imagine a 2D game like Isaac in a grid, every enemy would have its X and Y position, and of course our player would also have an X and Y position. And our task is to find the closest enemy to us and then maybe do something with it, but just for the sake of this example, what we have to do is find the distance to the nearest enemy and also find which enemy is the nearest. So then we can do some other things with it when we actually get the game and start modding for ourselves. Okay, so our second example is a bit more hands-on, so to say. And in this situation, what we have is positions of enemies and our own position. So remember when I said that you can imagine Isaac as a grid, two-dimensional grid? Well, this is the exactly same scenario. So we have the positions of our enemies. So in this case, let's say that we have 6 enemies in the room, and the position of the first enemy is located on the first cell of enemy X position and first cell of enemy Y position. So that means that the position of the first enemy is 4-1, and the position of the second enemy is 5-3, and the position of the last enemy is 16-18, whatever that means, maybe 16, that means that the 16th row in the 18th column, and our own position is 12-9. And let's say that we have an item that's very interesting, that's something that I kind of theorized, is that it shoots the nearest enemy for any particular amount of damage. But of course we only have this data. How can we actually find the nearest enemy? Well, here are a few things that maybe if you never did vector distances or anything like that might seem a bit confusing, but it's basically the same principle as finding the biggest number. The only thing, an extra step that we have to do here is finding the actual distance. So first of all, like before, we remember the first index. So up until this point, the first enemy, we assume that the first enemy is the closest to us because we have no relevant information, I guess. So we just assume that the first enemy at the start is the closest to us, and then we start comparing it once we go through the for loop with all the rest. So we'll get its distance, and if you don't know how you get the distance, what you do is, first of all, well, you can see the formula here, but if you imagine it in algebraic terms, what you end up doing is subtracting your position from the enemy's position and then applying a Pythagorean theorem on it, or today it's called Euclidean theorem, which is a way to find distance from your enemy, which means that the differences of your x positions are squared, then you add them to differences of y positions are squared, and you root all of them. And remember, we learned this operator for cubing, or to the power of, which is just like this little hat symbol. And of course you can square everything by squaring it or putting something to the power of a half. So putting something to the power of a half means that you're actually square rooting it to whatever you need. So this is the formula that gets us the position. I don't want to go into details to explain how exactly this is got, unless maybe you want to see, and I'll just create a separate video on the topic and explain how you can actually kind of get the formula to get the distance of enemies. But for the time being, just remember that this is the formula to kind of get the distance from us to our enemy. So in this case, we just get the distance to our first enemy, and however that much is, we go in our for loop and we get the distance to our next enemy. In this case, I start the for loop with 1, but like before, we could start it with 2, and that's a little bit better because we don't have to compare it to the first value at all. So what we end up doing is we calculate the distance to our second enemy, which is located on 5, 3. And if that distance, our new distance that we calculated, is lower than the minimum distance of our enemy that we found so far, and in this case it would be, just by hunch, I feel like this enemy is closer than this one, we will remember our new distance as the lowest distance, and we'll remember, of course, the index of this particular enemy. And then we, of course, will go to the next enemy, the third one, and we'll calculate its distance, and then if it's lower, then we'll remember it again. And the closest to us is actually this, in particular, the fifth enemy. And of course, we'll again do the same thing. When we get to this point, our I will be 5, and if this particular distance that we calculate will be lower than the minimum distance we found so far, we'll remember this distance, and we'll remember its index. And of course, when we go to the last one, this one is further than this one, so we won't remember anything. And if you just run this, what ends up happening is that we get the distance to our nearest opponent is 2 squares, which means it can be either diagonally or in horizontal and vertical direction, and the index of the nearest opponent is on the fifth one. So the fifth enemy is actually the clearest to us. So let's say if you have an item that deals damage to your nearest opponent. Now at this point you would know who your nearest opponent is, and you could, maybe deal 3 damage to him, or maybe play an animation at his location which like throws a thunderbolt on him and maybe shocks him and paralyzes him or whatever. So in this situation, you can see how you can actually use for loops and if statements and arrays to kind of access that information that is very useful to us, in the sense that you can access this data sequentially and then of course perform certain operations on them. And I hope that with this example you can see how this could be actually used in modding. Up until this point we can't do really much, but at this point examples, certain problems certainly turn up and we can start doing some real magical things. So if you have any suggestions, maybe an idea for an item, maybe you can write it, and then if I feel like it's something that I could show as an example, as a code, I can write the code for it, and you can maybe see how that would look like when it's actually written in Lua. Okay, so this is the end of this video, and this is all about arrays. I know that some of the things were confusing, especially 2-dimensional arrays and 3-dimensional arrays. That's something that always gets the newcomers going, but I urge you, whenever you don't know what's going on and you want to know something, please ask questions with examples, and of course with when you ask a million questions in a million different ways, and when someone explains it to you, with time things certainly click and things become so much easier to understand. But at this point, when it's still so very abstract, really, I urge you, if you want to learn, of course, that you're not afraid to ask questions, even if you think they're silly or maybe you feel like there's no point in asking them. I really ask you to please seek the knowledge, because getting the knowledge to kind of create something for yourself, especially when mods come, is a very rewarding feeling. And I feel like everyone should experience that at least once in their lifetime, to create something out of nothing with just their head. With that said, I had a great idea before. If you didn't see the examples for any reason, maybe if you have an idea for an item and maybe you were interested in how the code would look like, maybe just as an example code, I don't know exactly how it would look like, but maybe just an example to see, to learn, maybe you could leave your idea for an item below and I can maybe write the code and I'll showcase it in a few separate videos as an example of, the things we learned so far, to kind of how we can actually apply the knowledge we learned to kind of create something that's actually relevant to the game. With that said, guys, if you enjoyed it, please, leave a like, things like that, because that usually helps or whatever. But more importantly, of course, if you have any questions, please ask them, because I know I'm annoying by saying that you should ask questions, but you really should, because that's the only way we're gonna learn together. So thank you for watching, and I hope to see you next time.